All right, everyone. We are still in the midst of chapter five. So, a little bit of a disclaimer about how we're doing this chapter, because I mentioned last time the order that the book does this in isn't something that makes a great deal of sense to me. So, we're doing things a little bit differently. There's a couple of reasons for that. Um, the process of mounting things, which we did last time. One of the things I said, and this probably bears repeating here, is this idea that if you can mount a CD-ROM or a hard drive or a thumb drive or something like that, USB stick, um, the process of mounting all of those things uh, is uh, is pretty much the same. It works the same. The actual process of getting it onto the file system, looking at the device file, and then picking a place in the file system to put it. That's all true for everything. There's some additional configuration that we're going to do with hard drives to make, say, for example, if we were putting a new hard drive in the system, we're going to want Linux to know about it when we reboot. In other words, we need that to be persistent. It's probably not going to be true with the CD, probably not going to be true with the thumb drive, so the textbook doesn't cover it there. Um, but it's easy enough to just not do that part if you understand what the commands do. So a lot of what we're going to be doing here is also applicable to the part about USB sticks or thumb drives or whatever you want to call them. We skipped over some of that stuff with USB devices for that reason, for a couple other reasons too. Number one, USB sticks like that are a little bit less frequently used in industry. I think security people don't like them, and if you're trying to transfer files around on Linux, typically you're going to wind up using either the network or a portable hard drive or something like that. So it's not something that is of vital concern. There may be some situations where you need to have some knowledge about that, but that's something that is, I think working with hard drives are a little bit more important. That's reason number one. The next reason is that actually trying to simulate this sort of stuff on um, a, a, a VM is very difficult to do unless we all have the same sort of Linux or USB thumb drive that we're going to plug into our systems. Then we have to do some legwork in the VM, and then sometimes it works and sometimes it doesn't work. We're going to skip all that because simulating hard drives is relatively easy. Um, it, well, it's relatively easy, but it's still something that you can mess up. So I have had a bunch of students click on the wrong thing and accidentally erase their VM or put it in a configuration where suddenly the boot order doesn't work or it doesn't work for some reason. So what I would recommend that you do before you do any of the lab work in here in this section is to go into your VirtualBox Manager, and you can see what I've done here as I took the copy of CentOS that I normally work with and I cloned it. I'm going to say make this a full clone, and I don't have any snapshots, so that probably doesn't matter. And then go ahead and clone that. I just did that, so I don't need to do it again. It's probably going to take a couple minutes because it's copying a lot of data. But this way, what we're going to do here is we're just going to work off the clone. So if we mess anything up, we can go back to our previous version of CentOS. Um, that's the plan for what I want you guys to do. Adding extra hard drives is easier in a virtual machine because we can just create virtual hard drives. We don't actually have to have a piece of hardware that we plug into to the system. So here's the plan for today. What I'm going to do is start by going through some of the PowerPoint slides, well, the PDF slides now, I suppose, and just explain some concepts about hard drives and how Linux relates to them. And then what we're going to do is we are going to go into our VM and we're going to add a virtual hard drive, and we're going to go ahead and partition it and format it and do what we need to do to see if we can get Linux to see it. Um, the the if we've done everything correctly, then what we should be able to do by the end of class today is reboot our VM and have it come back and automatically find that hard drive that we've added. That's the eventual goal. It's going to take us a couple videos to get there, though. And first, we need to start just talking about some products. So, or some concepts behind how Linux is going to treat hard drives, and then we'll get rid of this and actually start working with Linux. So, in preparation for that, I'm going to go ahead and start up this clone here, and let me see if I can put that in a place where it's not obscured by my face. Something like, okay, we'll come back to you in a minute. Okay, so Linux will treat hard drives in different ways, given if depending on the hardware that it has. So one of the things that I think we probably saw, if you looked for block devices in your dev directory, we did, and we were talking about some of this last time. You probably saw something in there that I believe said SDA. Now, that is a particular type of hard drive that, again, since we don't actually have a hard drive, that Linux is simulating in a VM, and that is SDA is the name that it's going to give to the first SCSI drive. So if we go back to the previous slide here, if you see something that says HDA instead of SDA, that's going to be a different type of hard drive. Let's actually go ahead and see if we can log in here. Let me move this to where, okay, fantastic, and log in and go ahead and launch a terminal here. In a minute, anytime now Linux. And I'm going to say lsblk, and you can see that what we're dealing with is SDA. So based on our knowledge of what SDA is there, what we would expect is that well, again, since it's a virtual machine, it's simulating a SCSI drive. We're actually not using PATA configuration at all. PATA drives have to be set up in a little bit of different ways. You either have primary masters, primary slaves, secondary masters, or secondary slaves, and this is typically what they're called. We're not going to talk too much about PATA configurations, because if you've set up your Linux VM like mine, you probably have something that looks like this. So when you're used to using Windows, you plug in a hard drive and it's the C drive. And typically, if you plug in another hard drive, you're going to see something that's the D drive, right? And now, some of you are saying, no, 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 that's not true, but I'm oversimplifying here. Just stick with me. The way Linux works is that if you put in the first hard drive is always going to be called, this is assuming that we're using SCSI drives here. The first one's going to be called SDA. The second one's going to be called SDB. The third one's going to be called SDC. The fourth one is going to be called SDD, and you can kind of see the pattern here, right? That's the way that works. And if we were to go back and let's see, where are we? We do not need to install software updates. And if I went into my dev directory and did an ls on SD star, you can see that what we have here is just something that says SDA and then SDA1 and SDA2. Okay, so we can, if we are looking at this result here, we know that there's not anything that's an SDB or an SDC. All that what we know is we only really have one hard drive there. Okay, so what's this 1 and 2? Well, we'll talk about that in a minute. What I want you guys to know, the takeaway from this slide, is that SDA is going to correspond to the first hard drive. SDB is going to correspond to the second one. Now, SDDs, solid state drives, are going to be a little bit of a newer technology, and those are going to act like hard drives for what we're seeing here. So that's about all we need to say about that. Now, those of you that felt I was oversimplifying the C and D thing, and you were about how Windows does this, you're absolutely right. So if you have a Windows box and you take a hard drive and you use two partitions, right? Then one of them is going to show up as the C drive and the other one's going to show up as the D drive, even if they're the same on the same hard drive. Now, Linux doesn't do that. What Linux is going to do is, if you have the whole hard drive itself is going to be called SDA, and then if there are two partitions to this, one of the first partition is going to be called SDA1, and the second partition is going to be SDA2. If you have a second hard drive, it's going to be called SDB. If it has two partitions, the first partition of the second hard drive is going to be called SDB1, and the second partition of the second hard drive is going to be called SDB2. And you can pretty much figure out the pattern based on that. If you have three partitions on your third hard drive, it's going to be called SDC3. If you're trying to copy something from the third partition of your third hard drive to the second partition of your first hard drive, you're probably going to be copying it from SDC3 to SDA2 or something like that, right? I'm getting myself confused here, but I think you guys can probably see the whole pattern here. So when we're talking about the way Linux approaches this, um, for those of you that aren't aware, and I think probably most of you are, but just in case, this idea of a partition is going to be a section on a hard drive that acts like its own separate space. Okay, so when I set up a Linux drive, I can have a whole lot of different partitions if I want to. Um, and each partition is going to have a file system that's unique to that partition. When you set up a root or a Linux computer, um, you're required to have just two partitions. What's referred to as root, which is where it's going to mount slash, and swap. Now, we haven't talked about swap yet. Swap is a little bit of a strange thing, and it's used as sort of an extension to RAM in a Linux machine. Virtual memory is what this is referred to if you're on Windows. It's not completely analogous, but it's close enough for what we're talking about in here. It's an extra space for the system to write information that it can't keep in RAM. So, as a general rule, you're always going to want to have a swap partition in Linux. When we installed Linux, the installer was kind enough to put one there, probably without really telling us what was going on, but it's there. And then obviously root is there as well. Now, a lot of people that I know when they're building Linux systems will put different things in, they will set up different partitions for different areas of Linux. So like on some of the Linux servers that I use at work, administrators like to have a separate partition for slash home, and then all the home directories are in one partition. Security likes to have their stuff set up in slash var slash logs slash audit, because that's where all the audit files go, and they want to make sure that that's in its own place. So that's any one of these things can be set up. Any point in the system can be set up as its own separate partition, and that may seem vague and unsettling, but we'll actually go ahead and demonstrate that when we get later in the class. The thing that makes that valuable is that if I have a Linux box and say um, slash home is on its own partition or its own hard drive, let's say something happens to that partition. Files get corrupted, it gets full, something bad happens. If I have just that one partition, then things have the bad things have been limited to that one partition. It's a lot easier to recover from that than if the entire system has something that's gone wrong with it. So as a general rule, if we were building VMs here to actually use in the real world, we would probably have a lot more partitions. When we went through the Linux install process, we told Linux to just do this automatically. If you ever want to step back through the Linux install process and say manually partition tables or data, you're going to see that you have a lot more options. Okay, so let's see, what else are we talking about? So the book wants us to be at least passingly familiar with a couple parts of a hard drive. So this is actually fairly vague, but the next slide actually talks about actually has pictures, which helps. So when we're talking about a track, I don't know if you guys have ever seen a picture of a hard drive when it's not in a computer. I think this is probably something that you had to do in computer maintenance if that's a class that you took. But the thing looks like a sort of a series of platters. Uh, imagine little metal plates, and they'll spin around, and then you have these little read-write heads that go back and forth to read data as they're spinning. So when we're talking about a track, we're talking about a position on this. A position on the circle that goes all the way around. When we're talking about a sector, we're talking about a portion of a track. So you can see this is a portion of one track right here, and then this is another. Stop it. Another sector right here that is associated with a different track. A block is a combination of sectors, and then if you want to think of a cylinder, it's going to be a track that goes from kind of down on, because hard drive isn't going to just be one of these things, it's going to be a stack of these things. And if you want to picture sort of a shape that would be the corresponding track on each one of these cylinders, that's going to be what's referred to as a cylinder. Typically, Linux is going to store what's referred to as the master boot record, which is going to be well, MBRs are used to boot the system. They're kind of how Linux knows where the beginning of the hard drive is. That gets stored at the very beginning of the hard drive, the readable information there. This is a way that you can partition the disks. So what we've got here is a pretty standard way of partitioning hard drives. Slash here is where we're going to see looks like it's the largest space. So pretty much everything that we know and are familiar with is going to go into slash, except for something that has its own partition down here. So home is somewhere else, and then boot is somewhere else. The swap space is over here. And then we have 10 gigabytes of just or what are referred to as free space. We could use that later. So this is a typical way in which Linux is partitioned. Although for the way we did our installs, probably everything's just in the same sort of thing. So let's talk about. Okay, so now we're getting to fdisk, and we can actually go ahead and start using some of this stuff. So what we're going to do, or what I'm going to do first, is I'm going to go ahead and shut this guy down. Because what I want to do here is I want to simulate adding a hard drive to this system. So what I'm going to do here is I'm going to come into settings, and this is why we don't just have the window for Linux up. I want to make sure that we're taking a look at how this whole thing works here. So what you can see right here is I've got a hard drive right here. And that, since it's actually a clone, so I'm not messing with the original one, but this is simulates an actual hard drive that my computer is using. What I can do here is I can add another hard drive. And what I'm going to do is I'm going to come up to Controller, SATA, and I'm going to click on this thing right here, and I'm going to create a new hard drive. So I'm going to say Create, and then this thing doesn't really need to be that big. I'm just going to make it, say, 4 gigs. And it is going to come up with a unique name in there. It has an _1. That's not something that exists so far, and that's fine. So I'm going to go ahead and create that, and I should be able to see that I've got it right there. All right, that should be what we just created, 4 megabyte file. If there's some other stuff in here that you guys see, don't worry about it. I'm going to go ahead and set that up. So now this is a way of what we've just simulated is me taking a brand new hard drive that has never been used before and plugging it into my Linux machine. That's what we've simulated, and the reason we're doing this on a VM is because I do not want to have to go out and buy 67 hard drives, or however many people we have in this class, and give you each one. So this is a way of simulating what that's going to act like. Okay. So what we're going to do now is we're going to go ahead and boot it up. When it boots up, we're going to go ahead and talk about the process that we need to do to get it attached to the system.